This is a game for 2 players, placing proper fractions, non-unit fractions, onto a number line. So first of all, you need to draw a number line from 0 to 1. Player 1 has already rolled. When you roll, the player 1 rolled and they got a 2 and a 6. So the rule with the game is that you put the smaller number as your numerator and the bigger number as the denominator. So now it's player 2's turn, and they use a different coloured pen and they roll. Oh, so we have 1 as our numerator and 1 as our denominator. So this is where player 2 has to go. So this is 1 over 1. And player 1 is back turn again now, and they've rolled a 1 as the numerator and a 4. So we had 1 over 1, and now we have 1 part out of 4, which we know is a quarter. So we visualise roughly where we think a quarter would go, and I think it would go about there. And then it's now player 2's turn to roll, and they have 4 as the numerator and 5 as the denominator. So where would we place that? We're thinking about that as 1/5, and then we're thinking as 4/5. So it's 4 1/5. 1, 2, 3, 4. So I'm estimating that 4/5 would go about here. So the aim of the game is the person who gets their fractions 3 in a row. They are the winner. So player 1 potentially could win with this roll. So we have 2/5 for player 1, and this is roughly about 1/5, and so I'm thinking that 2/5 is about here. So we now have player 1 as our winner because they've got 1, 2, 3 fractions in a row with no interceptions from player 2. Now, an awful lot of understanding about number lines needs to be embedded, and what we need to do as teachers is to support children in moving from the models that we use to placing numbers on the number line, so they can treat fractions as numbers in themselves. So how do we do that? First of all, we need to make a big focus on unit fractions. So we know from research that children can't understand non-unit fractions without a secure understanding of unit fractions. So if I'm rolling my dice, possible throws, if I've just got 1 of my die and I roll it, then that would be 1 over 1. So each time it's a unit fraction, so I already know my numerator and it's just my denominator. So I could get 1/5. So obviously you can see that all the possible fractions that I can get are 1 over 1, 1/2, 1/3, 1/4, 1/5 and 1/6. So children need to be able to place each of these fractions on a number line. So I've already demarcated those out. So this is the half point, and so this is the 1/3 point, 1 part out of a possible 3, and this is our quarter point, and this is our 5th, and this is our 6th. So children need to have a secure understanding of unit fractions and placing those on the number line. So I'm wondering if you can work out what fraction I've left there. So how do we get children to move from models to understanding where to place unit fractions on a number line? Well, paper folding is an excellent opportunity. So my number line is 30 centimetres long, and my model of the paper strip here is also 30 centimetres long. So I'm going to fold my paper in half. Once I've found half of this, I can then demarcate my half on my number line. So they use the folding to map. So we know that this section within our paper folding is worth a half, and we know that the end of this section is the point in which we place it on our number line. And we can do that for all of our paper folding. So this represents the whole, and we fold this to find 1/3. And we might talk to the children about how the fact that this is 30 centimetres, so 1/3 is 10 centimetres long, and that maps our 1/3 out. So the children need to move from the paper folding, from our model to our number line in order to understand how to map fractions onto a number line. So we know that this is worth 1/4, and we map that onto the quarter, and so on, until we end up with each of our fractions. These are the ones I prepared earlier. So we have our half, our 6th, our thirds, our fifths, and our quarters, and so on. We end up with 2 halves there. So then we begin to think about how many halves can make one whole. And what we're doing is we're repeatedly iterating each of our fractions. So we've got 1/3. We know this is 1/3. So if I have 2 1/3s, that's 2 lots of 1/3. That's the same as 2/3. And then we can clearly see by iterating our 3/3, we come back to our whole. So 3/3 we know make a whole. So we're moving from our understanding of the unit fractions and iterating these unit fractions. So we can see here that our 2/4 are at the same point as our half. And then we can mark our 3/4. And again, we can see that 4/4 are equivalent to 1 whole. So we've moved from understanding unit fractions with our model to placing these on a number line, then using unit fractions, iterating those to explore non-unit fractions. And then we're ready to begin to play our game. What we might do then is to think about numbers beyond the number line of 0 to 1, i.e. looking at improper fractions. So this time when we roll our dice, we're thinking that our bigger number is our numerator and our smaller number is our denominator. And so we will take a number line like this one here that goes from 0 to 6, and we're thinking about where we would place 5/4. And of course, our prior learning that needs to be embedded is to understand that the 4/4 make the 1 whole. And then I'm thinking about 1 more quarter, and this is our 5/4 point. And so you can play the game again, but this time exploring improper fractions on a number line. But at each time, we're working from our models to our number line. And the number line enables us to treat numbers as fractions in themselves.